Hello everyone and welcome to a 3D Buzz experimental recording. This is a recording where we're going to be doing some, student-teacher interaction. We've got Mr. Nelson LeKay. Hey, Nelson.
Hey.
And we've got Mr. Zach Parrish.
Good evening, folks.
All right. And myself, Jason Busby. And for the next little bit of time, we're going to be talking about something in the world of programming where Nelson will be hosting this little mini show as, let's just say, an instructor. Zach will be playing the role of hostile student.
I was going to say, Nelson's kind of in the hot seat on this one.
Yeah, just a little. And I'll be playing the role of referee, and I can switch both sides. I can jump over on the Nelson side if Zach's just ready to choke Nelson because he doesn't understand something, and Nelson's wanting to choke Zach because he's explaining it in black and white, and I think there may be a different way that it could be presented.
So you're the troublemaker.
Or, yeah, pretty much. Or I could jump over to the Zach side if what Nelson's saying is, something that's going over Zach's head. His eyes are glassing over. I didn't even understand what the heck Nelson just said, and Zach's just not answering or asking a question. I'll jump in there. Like, wait, what? Because Nelson has a tendency from time to time to shift gears and to leet speak.
He doesn't quite start speaking binary. He's good about that.
Yeah, he gets close, though.
He gets close.
He's definitely at machine language or assembly language, not all the way down to ones and zeros or just pure hex, but still. So the idea of the show, again, this is just an experimental run at recording an interaction between an instructor and student with some sort of programming topic. And tonight's topic of choice is going to be LINQ in C#. Zach has heard it tossed around here several times. There's been a few times that I've said, hey, Zach, check this out. Utilizing LINQ in C# with this code I'm working on for a game, I've done the following. Isn't that awesome? And Zach generally looks at that and goes, "What? I don't even. That's so unreadable. Why would you even want to do that? It makes
take
no
a
sense."
BB, put it in a coffee can, and shake it around, and that's kind of what it sounds like when I nod.
But to me, I'm looking at it going, "What? How can that not make sense to you? It's just so elegant. It's so easy to read." And so, anyways, when I asked Zach what did he want to have a look at, and he says, "Well, let's start with this LINQ stuff because I'm getting tired of not understanding what exactly it is." So we've got Nelson here to give Zach an explanation. Now, Nelson has asked me if he can have free reign and jump over into other topics that may be required to help support his case in explaining LINQ to Zach.
Oh, I'm probably going to require a lot of side topics, so if you're looking for this conversation to only be about LINQ and absolutely nothing else, you might get frustrated with me.
Well, I've given Nelson free run of it, so he can do whatever he needs to beat the information into Zach's head.
Mm-hmm.
But the goal will be for Zach to have some sort of understanding the next time he looks at some of Lee's code, my code, Nelson's code, and we're making use of LINQ. Zach will at least know what he's looking at. So with that, Nelson, I'll turn it over to you, sir.
Alrighty, so I'm going to go ahead and create a project.
And while Nelson's getting a project fired up, let me take just a second to let everybody know this. And that is, again, this is experimental. Nelson at the moment was available tonight, but we have yet been able to get a mic to him, so he's just using his external or his built-in mic on his laptop.
Yeah, the audio quality that you're hearing come from Nelson really does not do his engaging baritone any justice.
So this is true, but I just wanted to throw that out there so that everybody is aware of the fact that the audio is going to suffer. That's just how it goes, but who cares? As long as we're able to understand what's being said, all is good. We'll get Nelson hooked up with a mic in the near future. Again, it's still a Skype call, so the audio quality will always suffer with that being the case, but it will improve some. All right, Nelson, back to you.
Alrighty, so like Jason said, in order to really understand LINQ, you kind of have to understand a few other concepts. So I'm going to go over those as quickly as I can to the point where Zach kind of gets where I'm coming from these particular features. So first of all, Zach, what do you know about implicit typing?
Nothing.
Okay. So you see,
what is implicit typing?
Yeah, I'm going to demonstrate really quickly.
Basically, he's telling you just shut up.
Yeah, I heard it.
We have an int variable, and we're going to call it something. And then we're going to say int something equals int dot parse. Oh. console.readLine, and then console.writeLine something, and then console.readKey. Oh.
You'll get used to it. Lee gripes about it all the time as well.
You know, I use ReSharper myself, but I kind of toned the.
You turn half the stuff off.
This is ReSharper turned up to 11.
But,
once you get used to it, it's awesome. But anyways, continue.
So, ignoring everything else that doesn't really matter at this point, you notice. Zach, do you understand that int something declares an integer variable
I do
and
indeed.
assign it to something else?
Mm-hmm.
Assign it to something else. Well, what if we didn't want to specify int? Because the compiler knows what we want. It knows that whatever int.parse returns, that is going to be assigned to something. And int.parse returns an int. So there's really no reason for us to say int right here. Implicit typing is about saying, instead of int, we say var.
Okay.
And var basically says, we're declaring a variable, figure out for me what type this is going to be. And that's implicit typing.
Why is that important?
This is actually kind of a war in the programming world, especially with C#.
Introduce me to the war.
The war is between code readability and code, it's from both sides. Some people say that it's more readable, some people say it's not more readable. I personally think using implicit typing is incredibly more readable, because if we were to do something like this, we just type that huge variable declaration twice. Why should we do that? The compiler already knows. So we basically wipe all this out and replace it with var.
Okay, that's a decent point.
But I will throw in that the main rule to keep in mind when doing this is you have to have the fact that we're doing that initialization right there. The compiler has to know right there where you are declaring that.
You couldn't
var.
just say var woe semicolon.
No.
You've got to assign it to something.
Yeah, the compiler must be able to see what it is that you are assigning to.
And I've actually been exposed to the use of vars when I was going through a lot of the Unity programming with Lee.
Okay.
But I wasn't familiar with the idea that was using the concept of implicit typing. I understand that now.
And in my opinion, implicit typing is less code to type, easier code to read, and easier to refactor. And you'll get people who will completely disagree with me, but that's just how I code. And
that's just the very nature of the programmer's world. Is you're never going to have all programmers agreeing all on the same thing.
Right.
Never.
And
go ahead.
Yeah.
Well, I was just going to ask, in your statement here, you say var, you give it a name, and then you give it an assignment. That assignment, I guess, is what internally types whatever this is, so that you know what type it's going to be. Is that going to have to remain the same throughout the program, or can you change types?
Yes, you have to remain the same as whatever you declared as. It is absolutely no different than this, other than the compiler has removed this part of that variable. Okay. So it's not dynamic typing, and C#4 does support dynamic typing, but that's over there. I mean, that's not.
I'm actually okay with that. The only other language that I have any experience with that does dynamic typing would be MaxScript, and I hate that. I actually prefer MELS, which is going to be static all the way through. You have to assign something, though. You don't have just something simple like variable. You actually have to say what data type you're going to use. But I see where you're coming from. I do understand that this would be less typing.
Yes, and it's easier to refactor because your types no longer really matter when you're working with functions and you're not doing this. You're not saying when you're doing more of these kind of statements instead of this. I can change this to a float by just saying float.
Right.
And bam, now it's a float. So one more thing before I get off implicit typing, it is that normally you can do this. This is a completely valid statement and declares two integers, one being x equals 10, the other y equals 20.
Mm-hmm.
Do you understand that?
Yeah.
Cannot use implicit typing with this syntax. Implicitly typed local variables cannot have multiple
and it says it right there in front of you, so that's convenient. So it'd have to be a separate line with another var y equals 20?
Yep.
Okay. Easy enough.
Okay. Next thing, what do you understand about enumerables? Specifically the for each loop.
Enough to get by, but walk me through it anyway. Pretend that I don't know. Because when you say enumerables, my brain immediately goes to enumerations, and I know generally what those are, but please, just go ahead and show me anyway.
An enumerable is any class that implements the IEnumerable interface that provides enumerables, which are enumerated over for each loop. So I'll give you an example right here. Oh. Oh.
That's a great sound effect.
It is, actually.
I need to get that recorded and actually put that into my computer.
So you kind of, I mean, ReSharper is right now telling me to see you.
It's all good. It's all good. Just, keep jamming, Nelson.
All right, so that is a for each loop that is iterating over an enumerable. Now, if we look at list, we actually control-click with ReSharper installed. We get this guy, and if you find it over here, you see that you have it set up to a different one, Jason.
Oh, Jason, you're in trouble, dude.
I'm not used to I haven't really used this guy very much. Well, it's not telling me what it is inheriting from, but trust me in that the list inherits from an IEnumerable, and what the reason it can work in a for each loop is because it inherits the IEnumerable.
Okay.
And
I understand the purpose of what a for each loop is going to do. It's going to walk through the list, and each time it finds an item, it's going to perform whatever function you put there inside the curly braces.
Right, but the reason it can do that
is because it inherits from IEnumerable.
Right, and so it's implementing what needs
that's a part of the
to.
functionality which is deriving from IEnumerable, which we can't currently see because you don't have the right thing installed. So in the end, we can just blame you, Jason.
If you'll quickly let me do something that'll illustrate the point of an enumerable,
please.
Is that doesn't necessarily have to be a collection. Collection and enumerable are two different things.
Okay.
List, collection. You can stuff stuff in it. An enumerable is something that it's a sequence of something that you can iterate over. And it can go on forever, and I can demonstrate that you said that you understand object-oriented programming, or at least to a degree, so we can go, I like that. Sorry. Whoa.
Indeed.
So we're going to create our own mini enumerable. And then I'm going to go ahead and let ReSharper fill out the members for me. And enumerable requires that we have two methods, one get enumerator and another get enumerator. The difference being this returns a generic enumerator, this returns a non-generic enumerator.
What's the difference?
Don't worry. That comes into generics, which I'm going to go over as the next topic before LINQ.
Okay.
And so now we have an enumerable, meaning an object that can be enumerated over. We have to create an enumerator, which is the actual object that iterates over this enumerable. So think of it like we have this list. A list is an enumerable, but when we go in the for each loop, it has to have a pointer to each item in that for each loop as it goes on.
Okay.
And to illustrate that, I can go ahead and say and this is the class that every single enumerator exposes. Dispose, we're not going to worry about because we're not worrying about garbage collection at the moment. Move next. When we say for each, what this is doing is this is saying this, saying oh.
Because he types too fast. You realize that?
That is what the C# compiler expands it to.
Okay.
So what I'm going to do is in my enumerator class, my move next is going to do something different. My current is going to do something different. And I'm going to demonstrate that by adding a private field called counts. I'm going to initialize it to 0. Actually, I'm not going to initialize it to 0. On my reset, I'm going to say count equals 0. My move next is going to say count plus plus, and it's always going to return true. Move next returns false if it has no more items in this enumeration, returns true otherwise.
Okay.
It returns true if it has items in the enumeration, returns false otherwise. Current returns the current thing that we're pointing at. So remember that the enumerator is a pointer. So it's right now it's going to be pointing at whatever we have. So we just say return count. So we have created our own little mini infinite number generator enumerator thing. And we can demonstrate how to use that by doing...
What you've done is you've manually built all of the functionality that's already inherent into a list, yeah?
Correct. And you see now that I can now use my class in a for each loop because it magically implements all of this stuff. And if I were to run this, I'm just going to get an exception because I forgot the most important part. And the most important part is that our enumerable has to return a new instance of our enumerator. And now I'll get what I want, which is that.
Yay! Never stop counting.
Exactly. And this was just to demonstrate that an enumerator doesn't necessarily have to be constrained by a collection that isn't in. Does that make sense?
Well, actually, I lost the last thing you said because of the really cool music you were playing in the background.
That was my phone. Sorry about that.
No worries.
So an enumerator just represents a pointer in time to something.
Sure.
And that is what that's the magic behind the for each loop.
Okay, yeah, that makes sense. The for each loop only works because of this functionality within the enumerator.
Right. If my WOA didn't implement this, then I should get a compiler error once I remove this. And I get a compiler error because it's not enumerable.
Right.
Okay, so that's a quick overview about enumerations. What do you understand about generics?
I know the word. Take me from bare bones. When you say generics, what do you mean?
What I mean by a generic is that you can write code that isn't tied to a type. And what I mean by that is that if you say or print int so I mean it's a pretty straightforward declaration of a method.
Yeah, even I can read that. That's almost exactly how you do it if you were doing it in Mel or something.
Right. Now, what if I said that this print int can work on any type that I wanted it to? Meaning, it doesn't necessarily
you wouldn't have to feed an int into it, is that what you mean?
Yes.
Okay, how would you go about that?
Accomplished by generics. And generics are denoted by these little guys. Okay. And inside here, you put a list of tokens. And by convention, they usually start with T. And I'm going to call T type. So this T type is now a magical token that I can reference inside of this function body, including the argument list. So I'm going to replace int with T type, and this code still works. There's no mention of int anywhere in this code. So this code will literally work on any type I pass into it. If I go ahead and I'll demonstrate this.
So it doesn't matter what type of data you pass in, that token is going to hold whatever type of data type it is.
Yes. And you'll see that
token's for.
If I say print int and I pass in a string, it's not going to like that because a string isn't an int.
Right.
But if I say print string, that now works.
Gotcha.
Because basically it's taking this token, replacing it with this, so T-type becomes string and then just works as normal. One more important thing about generics is that you can implicitly make something, you can implicitly invoke a generic method without supplying the type parameters. And type parameters are right here. Is when you're calling it, you say, I want this to be the int version of this method. Now it can only accept ints. And then I want this to be the double versions. Now it can only accept doubles. And the thing about this is that just like implicit typing, this is redundant because the compiler already knows you're passing in a string. There's no reason to say string right there. So I can just nuke this, and it's the exact same. And that's actually why it's grayed out, is because ReSharper is telling me that I'm an idiot and writing redundant code.
Gotcha. And that's only possible because you've set up the generic system, or the generic statement when you actually made the function itself.
Well, no, in this case here, it's simply the compiler says, hey, there's a string. We know it's a string, so...
Right. So I see that. So here I'm stealing the mouse. So I mean I get that because this was a string. The compiler's smart enough to go like, hey, you don't need to say twice it's a string. You've already handed me a string, so I know that. But that's all possible because of this. Right?
Yeah, because it's set up to take in a generic type.
Right. Okay.
So the method itself just says, look, it's just a generic type that's being sent in.
Right.
And then you go about handling it however. But then when you go to actually pass it, the reason Nelson didn't have to type it in twice is because the compiler is already going to be able to tell what it is based off of the data that you're passing.
I'm with you. I'm totally with you.
Okay. And generics have ridiculous amount of usefulness, especially with collections. So have you ever seen... Have you ever seen this?
An integer list?
Yep.
Sure.
That's generic.
Okay.
So that's using the same construct that I outlined above.
Real quick, I was just going to add in with this, and this goes back to a discussion that Zach and I had the other day, where Zach is very familiar with arrays, and Lee was making heavy use of generic lists all over the place. And Zach said, so what exactly is this list? And the whole idea being that the list is going to function the same for whatever type you want to send in, because it's been based off of the framework of generics here, where I'm going to specify the type when I come in here and define this particular list. So if it's, in this case, a list of integers, or if we had players in a game, a class of players, we could make a list of players. And the nice thing is, list, its class, the base class for list itself, doesn't have to be rewritten how to handle this data every time.
Right.
Okay. Now the last thing is extension methods. What do you know about extension methods?
Nothing at all.
Okay, so you understand that if I have a person class, I can say, oh. So you understand how with the person class, I can give it what's called an instance method called walk.
Yes.
And if I were to instantiate this,
you could say person.walk.
Yep. Now, what if I wanted this guy to be able to run, but I didn't have access to this class? I couldn't add another public void to it.
Well, based on what I know, you're screwed now.
Check this out. So if I make a static class, and a static class isn't really important right now, but it has to be a static class. The name is unimportant. Now what I can do is, in any static class that is in the scope, if I define a method right here with a special syntax, will become available on person.
Okay.
So watch this. If I make a public static void run, and then this is special syntax, this person, and then any variable name you want. I personally use that, but you can use whatever you want. And then right here, your arguments. So let's just do arg1. By declaring this method inside of a static class in the same scope as this program class, person now has a run method.
Okay, so you've kind of bolted it on after the fact.
And you are definitely welcome to go, whoa, back up.
Yeah.
Because I see your eyebrows. They're awesome.
I'm trying to figure out, just here in terms of your code, you've got two classes that you've declared, and your static class that you've just given the random name to up there doesn't really sit within either one of those.
Nope. I can put this anywhere I want. I can put this class anywhere in the same assembly, and as long as the namespace that this class is declared in this case, console application 2, so I'll demonstrate that real fast.
Okay.
I'm going to bump this out to namespaces. Now, do you mess with namespaces at all?
A little.
So I'm going to bust this out into a new namespace. And you'll notice I have to add a using statement right here because of that. It's not in a different namespace. If I do person dot, there's no more run.
Right.
Because this static class is no longer within the same namespace. What I can do is I can say I've actually never ever declared two namespaces in the same file before. If I add this using extensions up here, this now puts whatever's in here in the scope of this program. So if I do this, he now is running it.
Okay. So, and that's because you're able to take the method and within its declaration, you add this and then whatever the name of the method is you're trying to, I'm sorry, the name of the class you're trying to attach this method to.
Yep. And that's all the special syntax.
Now, what's the that part of it? What is that exactly?
That is this.
I know, isn't it great when you use words like that?
Well, that's why I use it. You notice you know about this, right? So if I have oh,
I'm familiar with this. That talks to the class that we're currently in.
Right. So I can do this dot field.
Right.
That is this in that.
Oh dear God, yeah. This is why you don't use words like this and that together at the same time. It sounds like a routine of who's on first.
That is going to be equivalent to what this is in this context.
Okay. The object we are working with.
All right, now we're doing Objective-C naming. Sweet.
Okay, the object we are working with dot walk dot whatever.
Whatever you need.
Yeah.
And
okay, because it's kind of like it's of type person.
Yep. And one more thing is, you might be saying that extension methods are dumb, but they are actually really, really, really important for LINQ. But another use for extension methods is actually extending on basic types. So I can go ahead and say static class extensions. And I actually commonly do this in my own code.
Well, it seems like it's a nice non-destructive way to add functionality to an existing class.
Exactly. I'm not actually going to show that particular implementation right now because it's not really important. Okay.
All right, so I now understand what class extensions are, or I'm sorry, what did you call those?
These are called extension methods.
Extension methods. Thank you. I'll get all this stuff down. All right, so I know what an extension method is now. What's the next step?
Well, it's actually looking at LINQ.
Exciting.
And the first thing I'm going to do is remove all these unused declarations. And then I'm going to also remove this because it's annoying. Actually, I'm going to do something cool. What do you know about object initialization syntax?
Say it again. You cut out right as you started asking.
Or array initialization syntax?
Not much in terms of C#, but go ahead as if I didn't, and then if it's redundant, it's just redundant. Okay.
This, again, using implicit typing, because normally, before C#3, we had to say this.
There was an int array, right.
But now we can just say this because all these are ints. The compiler figures out for us. So items is now an array of ints.
Okay. Yeah.
And I can loop over it to do whatever with ints.
Mm-hmm.
So let's say we wanted to, or hold on, like first, if we do items dot, we see we have all this array stuff. There is no LINQ stuff in here right now because LINQ is everything LINQ is an extension method.
Okay.
That's all LINQ is. It's a bunch of extension methods that are applied to IEnumerable T.
All right, keep going.
So essentially,
we discussed IEnumerable T a minute ago, didn't we?
Right.
Right.
And so this bar items array, so this is an array of ints, ultimately extend from IEnumerable T. LINQ, what it does is it provides extension methods for IEnumerable T. So it's available on every object that inherits from IEnumerable T.
So all of your enumerables now inherit this new functionality, such
And
as...
when you want to use LINQ, you have to include it
Because
by
it's a
doing...
library.
Well, it's a group of extension methods.
Okay.
So you saw before how I had to using extensions namespace.
Right.
In this case, we have to say using system.link because system.link is the namespace that contains all of these extension methods that we're wanting to use.
Makes perfect sense.
So if we do items.now, we get a bunch of stuff.
Yeah, a bunch of additional stuff.
And you see all of those use the little object or extension method syntax.
Okay.
Now a quick thing about LINQ, like for example, let's say we want to
Okay.
So sum is a part of LINQ. It's one of the extension methods that are available.
Okay.
I just realized there's one last topic in order to get to LINQ that actually does and cool stuff. There's one last topic to go over, and that is lambdas.
All right.
And you know what, Nelson? No. This is great. We're right at half an hour. We'll divide this up. And here's what I'm thinking. We'll call this the end of this session.
Okay.
Keep it around half an hour. And so we know we'll start back up with lambdas. But when we start back up, Nelson, what I'm wanting you to do is quiz Zach. Because Zach's really wanting to get this stuff down. And I think that would be fantastic because that'll force him to actually look back over this video. What do you think, Nelson?
Yeah, sounds great.
Yeah, sounds like a plan to me.
Okay, so I'd like to thank everyone for joining us with this and look forward to the next installment. We still need to come up with some sort of working title. We'll work on that once we go off camera here.
Yeah.
The important thing, though, I have to say one thing, is anybody who's watching this and doesn't quite understand all of the concepts just yet, LINQ is really what got me to understand all these concepts. So I'm introducing them first just to give you a taste of them. But once you start using LINQ, these topics will make perfect sense. I just want to say.
It's good to know.
Awesome. Well, again, thank you both, Nelson and Zach. You guys did both an excellent job. And again, we'll actually get the second installment of this perhaps tomorrow night if Nelson is available. We'll take a look at another half hour and continue on.
Okay.
All right, guys. Well, thanks again. And that wraps up this video.
Good night.